Hi friends, welcome to my channel. Let's have a look at problem 3249. Convert doubly linked list to array. So here the data structure involved is doubly linked list. So we all know linked list, right? So here double linked list means that for a node there are two pointers pointing to the next nodes and the previous node. So if you look at the class definition for a double linked list node, so you see in the initializer, so you can see the value field and also two pointers. The one is the previous node, and the other is the next node, right? So here we are given an arbitrary node from a doubly linked list, which contains nodes that has a next pointer and a previous pointer. So we want to return an integer array which contains the elements of the linked list. So if you look at these two examples, actually you will have a very good idea. So here the node given is the last node, right? So if you check the next node for 5, it would be none. But if you check the previous one, it's going to have 4. Then the previous one again 3, previous one 2, and the previous one 1, right? But you can first move to the very beginning and then do the linear scan to get the list. So here also is what given is also the last node, right? So but I feel that this examples is not very representative. So for clarity, you might try to do something like this. Let's see. So you can have some examples like this one, right? So here you can have something like this, but the given node, let's say 4, right? Which is not the last one, but one in the middle in a rigorous sense, right? So for this one, you should still can return 1, 2, 3, 4, 5. So here the number of nodes in the given list is in the range given by the closed interval 1 and 500. So this constraint defines the problem size. And also the value is going to be in between 1 and 1000. And the last one is very important. All nodes have unique node value. So here actually in our code, we are not explicitly using that because sometimes we might need to track the beginning or the end with the aid of a set data structure. But it turns out for this problem, we don't need that, right? Or we don't need to go that detail. So with that said, let's look at the coding. So what I'm going to do is to first get the height of this double linked list. So then we are going to do traversal. So first I'm going to initialize a result variable. So this is the list. We are going to return its final state. And then we have a node current, right? But at the very beginning, we don't know if this node is at the very beginning. So at the very beginning, we mean that the previous node for the current for node is null, right? So what we do, we can first move the node to the beginning. So basically what we can do is, well, node previous. So in other words, if the node has previous nodes, so we're going to move towards the previous. So we're going to set node equals node previous. So this block actually is very simple, but after we exit this block, then we are going to have a node whose previous node will be null, right? So this indicates that we are at the beginning of the double linked list. Now we can do a linear traversal. Then we can do val node. So we are going to add the node value to the result. So we can append node value. And then we are going to update the state of the node. And node to be node next, right? And then afterwards, we just need to return the result variable, right? So with that done, I guess that's basically about it for this problem. Let's do a quick check. Yeah, I'll pass the first example. Now let me modify this one. Let's see, we change this to be 4, right? We still get this one, right? You can also try 2 or 3. Let's try 2. You get 1, 2, 3, 4, 5. So now let's submit that. Yeah, it passes all the cases. So here, actually, if you see that there's a remove linked list elements. So this is an easy one. You can also try this one. But in this for this problem, remove linked list elements. So given a linked list, there are some node. We are going to delete some nodes with a given node value. So for this problem, actually a typical trick is using a dummy node. So you can basically try first by yourself. Now, if you need help, you might refer to our videos. So with that said, I guess that's about it for the current problem.